and welcome to the course Introduction to the Psychology of Language. I am Dr. Ark Verma from IIT Kanpur and we are in the third week of the course. This week we have been talking about speech production and comprehension. In the last three lectures you saw that I talked about different aspects of speech production. I talked about a couple of models of speech production and also some of the evidences that come to support those models. So we talked about the Weaver++ model given by Levelt in 1999, and we kind of saw some of the evidences that come from, say for example, speech errors, tip of the tongue phenomena, or even picture naming and picture word interference studies from the normal individuals. These evidences basically are a lot of experimental studies that were done and some of the errors that were observed and analyzed to basically tell us what part or what step of the speech production process could be damaged or, say for example, could be affected to lead to those kind of errors. In the last lecture I discussed a little bit about Dell's spreading activation model of speech production, and we also saw some of the phenomena that some of the basic assumptions that Dell's model had, which were different from Weaver++ model. Both were kind of slightly different models, but both of them kind of in some sense chalk out the process in very similar ways. As I said, today's lecture is going to be about speech comprehension. We will discuss a couple of theories about how speech comprehension really happens and basically what is it that goes for a particular listener to understand and comprehend whatever speech signal that is being created, how to decipher that. If you remember, in the starting of this unit I talked to you about the fact that the process is sort of cyclical. So the process is that going from an idea to really formulating the idea into particular linguistic words, and then going to the articulation part, you actually go to something that is actually physical. So you create a physical sound which basically is what that reaches the listener. So the listener has to basically do what? The listener's task starts from hearing the sound, and then from deciphering what the sound really contains, go to the concept that most probably the speaker of these sounds would have had. So it's sort of a cyclical process in the end, and the first part of that cycle we have done in the speech production part in the first three lectures. The second part of that cyclical process comes under speech comprehension, and this is what I will discuss in today's and tomorrow's lecture. So how does speech perception begin? There is this cartoon basically made by Gary Larson under the Far Side Gallery. I kind of borrowed it to illustrate a particular point. There is this gentleman who says, what do we say to dogs? And it could be dogs or cats or any other person whatsoever, and you see that the person is saying a lot of things. So he's saying, say for example, okay Ginger, I've had it, you stay out of the garbage, understand? Ginger, stay out of the garbage or else. And it's almost a thread or something, and you see is the next part is pretty interesting, because Ginger is actually not hearing anything else, only Ginger is listening to his name. So this is something which is very interesting, and it's interesting to me because in a sense of whatever you say, it should be intelligible, it should be understandable to the listener. That is what the essence of speech comprehension has to be about. So we are kind of going to look into some of the processes that basically go into making Gingers understand how the speaker is speaking, from where he is coming from, and Ginger has to kind of achieve this in order for conversation or communication to work effectively, because if only one person speaks and the other person does not really understand, it's not really a great loop that is being completed, and that's communication which is sort of a loop. Okay, so we'll try and understand some of those things related to understanding what the other speakers say. Now the theory of perception, there are a couple of theories of perception or maybe more that we will discuss in these two lectures, but I'll begin with this very interesting theory of speech perception that is called the motor theory of speech perception. Now I have been saying, if you remember, that speech or language or speech production so to speak is a rather sophisticated specialized motor activity. If you remember, I said it takes around 100 muscles to be controlled in order for you to articulate exactly without an error whatever you intend to speak at any point in time. So it is a motor act. So it's not really surprising that there is a motor theory of perception, but let us see what the motor theory of perception has to say. So the motor theory of perception basically proposes that gestures rather than sounds should be the fundamental unit of mental representation as far as speech is concerned. Okay, so for example, as I said, what the speaker creates in the end is the sound. However, people have expressed doubts sound is not really a very faithful representation of what is coming out of different speakers' mouths, because of the reason that different people have different kinds of voices, they have different kinds of vocal tracts, and they can create entirely different kinds of sound signatures even if they are speaking about the same thing, or even if they are speaking the same sentence. So that kind of probably led to some of these doubts, and there is this interesting proposal, most especially by Alvin Lieberman, who says that no, let us not really go by sound, because sound is not really a very faithful representation. Let us go by motor acts. And by motor acts, he basically means that when you speak, you move your articulators, the tongue and the lip and the teeth and the vocal cords and all of that. You move your articulators to particular places in very specific ways. I will, in the lectures that are going on in this week, attach some of the indicative videos of that will help you understand or manner of articulation or voicing really matter. And if you look at those videos, they are not our videos, they are basically somebody else's. But if you look at those videos, what you will understand is that there is a lot of difference in different kinds of speech sounds depending upon how they are produced. So the gestures that actually go in for us to be able to create a particular speech sound is something that is very important. So much so that Alvin Lieberman believed that it is these gestures that will make the sounds, that will make the speech identifiable, recognizable and discretely different from each other. And that is why he said the speech perception basically should be based on our perception of these gestures, these motor acts. So he says when you speak, you attempt to move your articulators into particular places in very specific ways, and each of these movements basically that you do constitutes what is called a gesture. And we should kind of try and analyze speech in terms of the gestures that basically were made to create this speech. Okay. So the motor part of the speech production system, it takes the sequence of words that you want to say and it comes up with a gestural score. We talked about that in one of the earlier classes. This tells our articulators how to move. So as I said, gestural score is a sort of a executionable program. Okay, and this executionable program basically tells you, okay, move articulator 1 to this point and constrict the flow of air to this much and then leave it, and then this is how it goes. So this sort of a program is very important in producing all kinds of speech. Now, according to this theory, if you can figure out what gestures were used to create a particular speech signal, you can actually figure out what the gestural plan was, which will take you back to the sequence of syllables or words that the speaker was intending to say. So you're kind of not really very faithfully looking at the speech sound that is created. That is obviously something that you hear, but what you're trying to do by listening to that speech sound is you're trying to make out what gestures were made to come up with this kind of a sound. Once you kind of figure out the gestures, say for example I have to say ta ta, okay, so what do? I am kind of creating ta by keeping my tongue at the back of the teeth, and I am constricting the flow of air only partially, and then I am kind of leaving it for me to be able to say ah. Ah does not require any constriction of air, but ta, for example, requires. So I am kind of doing this in a sort of a sort of a manner. Okay, so what you will really need to do is in order to really specifically understand what I am saying is that you kind of make sure of what is the gesture that I am making. And the motor theory says if you can do that, you will be closer to understanding speech as compared to if you are only relying on sounds. Okay, so by knowing what these gestures are, you can tell what was the set of words that has produced that set of gestures. And let's take an example for the core part. Let's say we take two sounds in hand. Let's say we take D and do. The core part, the basic, the stem of this sound is the D. Okay, and basically how is the produced? Very similar to T, but slightly in a slightly different way. So it's by tapping the tip of the tongue against the back of the teeth, as I said for T as well. But you can kind of make sure as how duh, because duh, in duh the teeth is slightly more further back. In tuh the tongue is slightly further forward, still at the back of the teeth though. Okay, so the idea is you have to kind of figure this out. You have to spend your resources in really figuring this out. Okay, so other parts of the gestures like the lip position, which you make in terms of if you're saying oo as in do or d as in e, are actually also affected by co-articulation, but the core component of the gesture, the duh part, is same and is common regardless of accompanying phonological sounds. So, rather than trying to map the acoustic signals directly to phonemes, Alvin Lieberman and his colleagues proposed that we should map acoustic signals to the gestures that produce them, because they believe that there is a much closer relationship between the gestures and the phonemes, because the gestures are directly responsible for creating the core part of those phonemes. Okay, in their words, they say the relationship between perception and articulation would be considerably simpler than the relationship between perception and the acoustic stimulus. Just kind of spend a second thinking about this. This is exactly what I was saying a minute ago, that all of us have different kinds of vocal tracts. There are so many disturbances in the environment. It is often possible that you will confuse what you hear from the person. However, if you kind of can get a reasonably decent picture of what the person was saying and you kind of decipher the gesture, you can be relatively sure of what has been said. That's basically what the point is from Alvin Lieberman and colleagues. So they say further, perceived similarities and differences will correspond more closely to the articulatory rather than the acoustic and similarities among the sounds. So they say that you have to base your entire understanding of whatever you're hearing on these articulatory gestures, because they are closer in time. You know, you make this gesture, there is a sound that comes and that is what you hear. This part is not really, the middle part is not really very faithful. So if you can kind of skip that part in some sense or use that part to come to the articulatory gesture part, then you will have a much stronger theory of what was said. Okay, that's basically what Lieberman is saying. So the differences between two acoustic signals will not cause you to perceive two different phonemes as long as the gestures that created those two different acoustic signals are the same. So you kind of, if you're going by gestures, that will cause you less confusion. You will probably be closer, you will probably be better in understanding what the sound was by inferring what are the gestures that created that sound. Okay, so let's move further. Motor theory, it also seeks to explain how a person can perceive an acoustic stimulus as a phoneme in one context or as a chip or a buzz in another context. Okay, the same phoneme is said, but in one context you perceive it as a chirp or a buzz, zzz, something like that, or as a phoneme like ba, da, something like that. Okay, so to explain that, the motor theory proposes that speech production is basically accomplished by a naturally selected module, and module is typically, you can just understand, this is module theory was given by Jerry Fodor. If you really want to understand a little bit more about it, you can go into some of the cognitive psychology lectures that I've given. But module is an understanding of that different cognitive functions are organized in different modular systems, and these modules are sort of boxes which are informationally encapsulated. Again, I don't want to throw jargon, but that basically means that if there is a job, say for example, if there is visual perception, and if there is learning, and if there is, say for example, understanding, all of these three things will be modular in nature. The output of the perception process, so the perception process will be self-sufficient in itself. It will just give an output which can be kind of taken care of by a language module, or say for example a speech perception module, as Lieberman and guys say. And the speech perception module is sort of self-sufficient in itself, and it only interacts with the other kinds of cognitive functions by virtue of input and output. Okay. Now, so they say that the motor theory says that speech production is basically accomplished by what is called a naturally selected speech processing module, and this speech processing module monitors the incoming acoustic stimulation, and it reacts strongly when signals contain the characteristic complex signatures that make up speech. So there is this particular module in your head somewhere, just imagine that for a bit, and that particular module is very closely monitoring everything that you are hearing. And you hear so many different things. You hear motor sounds, you hear horn sounds, you hear animal sounds, you hear all different kinds of sounds. this particular module is latched on to reacting when it detects that you are hearing speech. This is where the the module kind of springs into action. Now, when the speech module recognizes an incoming stimulus as speech, it preempts the other auditory processing systems, preventing their output from entering consciousness. So, it is basically saying that there is this speech processing module that basically comes into action when it detects something as speech. Because it detects something coming as a speech, it takes the input and it tries to process that input differently to how other kinds of sounds will be processed. So, the other kind of sounds could be basically things that will probably do a frequency analysis, they will probably kind of do a pitch and other kinds of analysis. With speech, you will probably not do that, or you will probably do that in a different way. So, as soon as this particular module discovers, okay, this particular incoming acoustic signal is speech, it preempts every other process. It says, okay, you don't really have to do anything here, I will handle it, and it takes the input to a different place, again very metaphorically speaking, and it kind of tries and processes it in a very simple, in a very different sort of manner. Now, while the non-speech sounds are analyzed according to the basic properties, as I was saying, basic properties of frequency, amplitude, timbre, and while we are able to perceive those characteristics of non-speech sounds accurately, when the speech module latches onto the incoming acoustic stimulus that may be speech, it prevents this kind of spectral analysis of that speech signal. Okay, that basically would be done by the general auditory processing module or mechanisms, as you would say. This principle of preemption, it explains why Forman transitions are sometimes perceived as chirps or high-pitched whistles when played in isolation, but as phonemes when played in the context of other speech sounds. So, say for example, formants are basically frequency spectra of incoming speech stimulus. So, what you could do is you could kind of analyze these formants, and you could kind of play them using a particular computer program, and you could hear what these formants, what kind of sounds these formants are representing. So, the principle of preemption sort of tells us that sometimes when you play these formants, you might hear them as, if you are just playing them in isolation, you might hear them as chirps or buzzes, but if you play them with the entire context, you might hear them as particular phonemes or speech sounds. Now, this preemption of normally auditory perceptual processes for speech stimuli can sometimes lead to what is referred to as duplex perception under special and controlled lab conditions. Now, duplex perception is when you can hear the same signal, same acoustic signal, at times as a chirp or a buzz, and at different times as a particular phoneme. So, Lieberman and Mattingly in 1989, they did this very interesting experiment. What they did was they tried to create their experimental stimuli using artificial speech stimuli that either sounded like ga or da, depending upon whether the second formant transition decreased in frequency over time or increased. So, you can say, for example, imagine this as this is a set of formant going, it could either increase to have the speech sound, or it could come like this and either decrease. So, what they basically do is they take this part, the flat part away, and they take the ascending part or the descending part away. What they do is they edit their stimuli in such a way that they create separate signals for the transition parts, these ones, and the rest of the syllable, which is called the base. So, this one is called the base, this is called the transition, this one is called the base, this is called the transition. This is what the spectral analysis looks like. So, what they do is they separate the base and they separate the transition, okay, and bases. So, for example, I am talking about da and ga. So, the base of da and ga will also be different, the transition of da and ga will also be different. So, you kind of get 4 different components. What you do is you play them to participants in separate ears. So, the idea is they played the 2 parts of the stimulus over the headphones with the transition going in one ear. Suppose the transition comes to my right ear and the bass comes to my left ear. This is how they do it. What did they find out of that? The question was, they basically were trying to ask the question, how would the participants perceive the stimulus? Will they combine these two and listen them as a proper phoneme? Will they listen to them as separate frequency things, which could be chirps or buzzes or something like that? Now, what they find out is that people perceived 2 different things almost at the same time. At the ear the transition was played into, people perceived a high pitched chirp or a buzz. So, this part wherever, say for example in the right ear, I will perceive a high pitched chirp or a buzz, but at the same time they also perceive the original phoneme, which is basically because they probably in some sense of time they combined this and they heard the actual phoneme that was played and split also. So this is an example of what I was saying as duplex perception. Okay. So Lieberman and colleagues argued that simultaneously perceiving the transition as two ways, as the chirp and a buzz and as a phoneme, it reflected the simultaneous operation of both kinds of speech modules. You know, the general auditory module, which analyzes all kinds of incoming acoustic stimulation, and the speech module, which basically only is specialized for analyzing and understanding the speech sounds. All right. So moving further, duplex perception happened, as I said, because the auditory system could not treat the transition and bass as coming from the same source. Because the auditory system recognized two different sources, it probably had to do something with the transition that it would not normally do. So it analyzed that as a non-speech sound in terms of frequencies. That is why you hear the chirp and the buzz, but simultaneously speech processing module recognize a familiar pattern of transitions and formants, and as they combine the bass and the transition, and that is what resulted in the auditory system reflexively perceiving this as the phoneme that was split. Okay. So that leads to the perception of the unified syllable. Now moving further, according to the motor theory, the categorical perception is another product of the speech perception module. What is categorical perception, if I may ask? If you go back, if you remember the last week's lecture, I talked about categorical perception. What is categorical perception? Categorical perception is our ability to perceive different phonemes as categorically different from each other. You know, perceiving pa and ba as different phonemes. That is what categorical perception is. Now categorical perception happens when a wide variety of physically distinct stimuli are perceived as belonging to one of fixed set of categories. So these stimuli are basically happening, are coming from this category. So pa and all variations of pa are in one category, ba and all variations of ba are in another category. Let us take an example. Every vocal tract is different, as I have been saying, from every other vocal tract, and as a result the pattern of sound waves that come out of your mouth when you say pink or my mouth when I say pink are very different. How does the system understand it? How do we both hear pink even if you are saying it or I am saying it? Nonetheless, so this is basically what happens. The phonological perception system is blind to the physical differences and perceives all of these variations as one category. Okay. If you remember the whole experiment with the Kikuyu children, you might go back and refer to that if you do not remember it right now. Now, it may be noted that because all of our voices have different qualities than each other, but at the same time we categorize the speech sounds from each of us in much the same way. This happens because any sound that you would make, say for example in English, will broadly need to be mapped on to this very limited space of 40 phonemes. So you will probably lump together so many variations and tell that this is the category this variation belongs to. You know, it's the whole concept of phonological prototypes being created. Now, in addition, the acoustic properties of speech stimuli can vary across a wide range. Okay, our perception does not really change in very little steps, in small steps, with each with very small changes in this thing. So it does change, but it does not really change very slowly. Okay. So we are insensitive. That is one of the reasons that we are insensitive to some kinds of variations in the speech signal that are happening. But suppose the speech signal changes enough, you know, from pa 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 pa, it changes to ba. You know, if the variation is large enough, then obviously we will start perceiving the two sounds as different stimuli. Okay. Let's take an example. I am taking this ba and pa example again and again. So the difference between ba and pa is voiced while pa is not. What is voicing? Voicing is basically when your vocal cords vibrate after you said something. Okay. Other than voicing, the two phonemes are essentially identical. Both are produced using exactly the same gestures. So in that they are both labial plosives. Again, the video is talking to you about manner of articulation, place of articulation. You kind of get sure of these concepts a little bit better. Labial plosives meaning that we make these sounds by closing our lip and allowing the air pressure to build up behind our lip dam and then releasing it slowly. Okay. The difference between the two phonemes has to do with the timing of the burst, the timing when you allow the air to come out, and the gap between which your vocal folds will start vibrating. So I say ba versus I say pa. Okay, there is a difference between the time that the vocal cords will start vibrating. For the b sound, the vocal cords begin vibrating while your lips are closed. They already start vibrating, so the vibration is already building up. And p, there is a slight delay, a slight delay of around 20 milliseconds or a little bit more. So p, okay. This delay basically is referred to as the voice onset time. So in other words, you could say the difference between b and p is that of voice onset time. Okay. So this VOT is a variable that can take any value whatsoever. So it is called a continuous variable. But even though it cannot vary, incontinuously in this way, we do not perceive that sort of variation. So there can be different kinds of voice onset delays between different speakers saying this. Okay. So we cannot really, what happens is we cannot really greatly hear the difference between a VOT of 2 milliseconds or 7 milliseconds or between 7 milliseconds and 15 milliseconds. So what happens is that we hear a range of VOTs on the same percept. Okay, those different acoustic signals are called allophones. Allophones basically are different signals that are perceived as being the same phoneme. So different versions of p, all of that with slightly different VOTs will all be perceived as the same category. These will be referred to as allophones. Okay. However, if the difference basically is slightly larger, if the difference is basically around a 20 milliseconds mark or more, then what happens is that you start perceiving the same kind of gesture as a different phoneme. So till a particular point when the variation is between b is from 2 milliseconds to around 18-19 milliseconds, it still gets perceived as b, but if the difference is more than 20 milliseconds, starts getting perceived as p. That's the point that I was trying to say. Okay. So that being said, let us move on to another very important effect that is basically there, and it demonstrates a few properties of speech perception, is this effect called the McGurk effect. Okay. I would strongly advise you to go to the YouTube and type McGurk effect, and you'll see some of the videos that are very interesting. People have made a lot of videos showing the McGurk effect, and the McGurk effect is basically something that I'll talk to you about it in a bit, but that's basically when you hear something else and you see something else, your brain kind of makes something completely else out of it. So we'll come to that. Now before moving that, let's just talk a little bit about the motor theory of perception. So it says that understanding speech requires you to figure out the gestures that have created an acoustic signal. That's what I've been saying. Now the system basically what does it do to understand the gesture? We've not talked about that. We have been saying that okay, you have to understand the gesture in order to understand the sound, but how do you understand the gesture? What are the sources of information that will help you understand, okay, this gesture would have created this sound? Okay. So acoustic stimuli offer cues in themselves to what gestures might have created them. Other perceptual systems could also possibly point out. Okay. So and if they can, say for example, the motor theory says that a speech perception system will take advantage of information about possible gestures from anywhere that it can. All right. So what happens? The two non-auditory perceptual systems, vision and touch, have also been shown to affect speech perception because they tell us some information about the gesture that might have gone in. Okay. So the famous demonstration of this is the McGurk effect, as I was saying, and McGurk effect also falls into this category of multimodal perception. What is it exactly? It happens when you watch a video of a person talking, but the audio portion of the tape has been altered. So the person in the video is probably saying ga, but the audio signal that is being played is of ba. So the video that you listen is ga, but the audio signal that you actually hear is ba. So what happens is there is different information coming from the vision. You are seeing a different kind of gesture, and audition, you are hearing a different kind of sound. What the mind does is it obviously gets confused as to, okay, I am seeing this, but I am listening something else. what does the mind do here? The mind basically combines these two sources of information, and the people actually end up hearing da. Da was not said, it was not in the audio file, it was not in the video file, but basically what the brain does is it tries to combine these two discriminate sources of information, and it ends up with you being able to say da. Okay, that is the McGurk effect. I am sure I have not really given you a decent demonstration of this. I am sure you should certainly go to YouTube and look at some of these videos. Okay. Yeah, so if the visual information is removed, the auditory information is perceived accurately. So if you close your eyes and you again listen to this, then you will be able to actually hear ga. Okay. So the McGurk effect is also incredibly robust. It happens even when people are fully warned that the auditory and visual information will not match, and if they are really trying to not hear the da. But many times people try and do this, but they always end up hearing da because the system is very robust. It kind of tries to combine these two sources of information. Okay. So why does the McGurk effect happen? The McGurk effect happens because our speech perception system combines the visual information and the auditory information when perceiving sound, rather than relying on only the auditory information or only the visual information. So that is how it came up in multimodal perception. Most of our speech comprehension is actually rather multimodal, as long as you are actually having you are at least having a visual of the person who is speaking. Of course, the auditory information by itself is sufficient for perception to occur, but the McGurk effect shows that the visual information influences the speech perception. Okay. As soon as you close your eyes, you will not really hear the confusion. You will hear the exact thing that is being played in the audio file, but however, what really happens is that the system is very keen on taking on information from other sources. So it does, as long as your eyes are open, it will inadvertently combine the visual information with the auditory information, leading to the McGurk effect if these two are not matching. This is an example of multimodal perception because two sensory modalities, hearing and vision, contribute to the subjective experience of the stimulus. Another variant or another way that McGurk effect can happen is by combining the haptic perception with auditory information. So I said in the beginning, vision and touch. You can actually also get clues to what is being said by the tactile modality, by the touch modality. So what happens is, this is something that is used basically with the people who are not being able to see perfectly. This kind of speech perception is basically referred to as tedoma. Okay, and this happens in specialized laboratory conditions from time to time, and the idea is that basically when the person is speaking, you keep your hand, you keep your palm in front of their mouth, so you kind of get the gesture that the person is going to say. So Helen Keller and other hearing and vision impaired individuals have learned to speak by using their sense of touch to feel the articulatory information in speech, because you need to know what gestures are being created to create what sounds. The hearing is all right, but the speech is not, so you kind of really need to get that. Or probably in some cases your hearing is not all right as well, but the tactile modality is a good clue to what gestures were needed to produce this kind of sound. So according to the motor theory, information about speech gestures should be useful regardless of the source, auditory or otherwise. That being the case, information about articulatory gestures that is gathered by the perceiver's sense of touch should affect speech perception. Okay. So initially, for normal individuals who have their hearing and their vision both normally functioning, vision serves as a very good vision serves as a very good information source about the gestures. For people who are hearing or visually impaired, so does touch work for them in the same way? That was the question. And to test this, basically Carol Fowler, she had her experimental participants feel her lips while they listened to a recording of a female speaker speaking a variety of syllables. So the lips says da, and the hearing says, the lips says ba, the hearing says ga, and what you hear is a combination of these two saying da. That's the McGurk effect that really happens. So blindfolded and gloved experimental participants heard the syllable ga over a speaker, while Carol Fowler actually mouthed ba, and what they do is they hear da. Okay, so the McGurk effect is clearly there with them as well. Okay, as in the visual version of the McGurk effect, what participants actually perceived is the combination of the information from the tactile modality versus information from the auditory modality. Okay, so they actually again hear the syllable "duh." Now, the motor theory explains both versions, the visual and the tactile version of the McGurk effect, as stemming from the same basic process. They say the same thing is happening here as well. The goal of the speech production system is not a spectral analysis of the auditory input, it is trying to figure out what sort of gestures created that kind of sound in the first place. So, what they do is they combine whatever information about gestures they can come about by vision or by audition or by touch, both, everything is kind of combined, and they basically come up with the output on the basis of this combination of information. Motor theory handles the visual and haptic effects on speech perception by arguing that both modalities do contribute to the information that helps the perceiver figure out what is being said. Under natural conditions, the visual, touch and auditory information will all be available. Not really touch, because you're not really touching people when they're speaking, but say for example all of them are available. If you, for example, decide to really check, all three information will be available and will basically be consistent and can be combined to lead to a reliable estimate of what the gestures were, and so motor theory of speech perception will work perfectly well. Okay. However, the McGurk effect is an artificially created effect because the information from the visual and the auditory and the touch and the auditory modalities were not consistent by design. That is why you mishear something. That is why you mishear what is referred to as the McGurk effect. Okay. So, this is all what I had to say about the motor theory of speech perception. This was the 4th lecture of the week. In tomorrow's lecture, I will talk to you about some of the other theories of perception. Thank you.